We have the infinite series of 1 divided by n squared plus 4, and we want to use the integral test to show that this infinite series converges. And so again, if we use the integral test, then we want to show, if we want to show that the series converges, then we have to show that the corresponding integral of f of x converges. So first, let a sub n be the sequence 1 divided by n squared plus 4. Then the corresponding continuous function be the function 1 divided by x squared plus 4. And we need to show that this integral right here converges. And the function here is 1 divided by x squared plus 4. The function 1 divided by x squared looks like this. So this is 1 to infinity. We need to show that the area between the graph and the x-axis, that this area converges to some number. So this integral right here, 1 to infinity, represents the area. It's the area between the graph and the x-axis from 1 to infinity. To get the antiderivative here, we need to use this formula. One divided by a squared plus u squared du. This is equal to 1 over a times tangent inverse of u over a plus c. So we look at our integral, we can let h squared be 4 and let u squared be x squared. And then take the square root of both sides, then we get the square root of a squared is 8, and the square root of 4 is 2, so 8 is 2. And then we need to let u squared be x squared. And then take the square root of both sides, we get u is equal to x, and then the derivative of u with respect to x is 1. The derivative of x is just 1. And so we have du is equal to 1 dx, which is dx. And so the integral 1 over x squared plus 4 dx, this becomes x squared, we call it u squared, a squared, 4, that's a squared, and then dx is just du. Dx is equal to du. And this is equal to this. But 8 is 2, so we have 1/2, and then u is x, and then a is 2. So the integral of 1 divided by x squared plus 4 is 1/2 tangent inverse of x divided by 2. So now come back over here. This is the same as the limit b approaching infinity of 1 to b. And this is the same as, this is equal to the antiderivative of 1 divided by x squared plus 4 is this, 1/2 tangent inverse of x divided by 2. And then we need to evaluate from 1 to b. So first, we'll plug in b, then we'll get b, and then next we'll plug in 1. Now, as b approaches infinity, b over 2 will approach infinity. So what is the value of tangent inverse of something that approaches infinity? So we have b approaching infinity. This quantity right here which is tangent inverse, and then something, and then this the quantity b over 2 will approach infinity. So this quantity right here will get larger and larger and larger. Then we want to know what is the tangent inverse of that. This will approach pi over 2. This is the graph for f of x equal to tangent inverse of x. And so we can see that as x approaches infinity, f of x, which is, this is right here, this is pi over 2, or 1.57. And so the y, or the f of x, will approach pi over 2. So this is the graph, y equal to tangent inverse of x. And we can see that as x gets larger and larger and larger, then f of x, or y, will approaches pi over 2. And so we get 1/2, and then this quantity right here, tangent inverse, that will go to pi over 2, and then minus, and then 1/2 times tangent inverse of 1/2, we just go to the calculator. And here we're not looking for the exact value of this thing right here. We just want to know if this integral converges or diverges. We just want to know if it's equal to a finite number, a real finite number, or is it equal to infinity? And obviously 1/2 times pi over 2 minus 1/2 times tangent inverse of 1 over 2. And then if we want to know exactly, if we want to know what this, all of this equals to, we can just go to a scientific calculator and put all of this in, and it will give us a finite number. It would just give us some real number. And so if we use a scientific calculator, and this comes out to be about 0.5535, and therefore we can say that this integral right here, this integral converges, and therefore by integral test, this series, infinite series right here, converges. And again, when we say that this series converges, all we're saying is it's equal to a real number, some real finite number. And this integral right here is equal to 0.55357. Does not mean that this infinite series is equal to 0.55357. All we know is that it converges, but it converges to a different number than this 0.5535.